Hey guys, so in today's video, we're going to continue our organic chemistry journey and start with isomerism. Now, there are three different types of isomerism that we'll come across in organic chemistry, and we're just going to discuss the first type of isomerism, which is the simplest of them all, which is structural isomerism. Structural isomers are also called constitutional isomers, just a naming basis. And so structural isomerism is an isomerism which arises due to a difference in structure. So when the molecular formulas are the same for two different compounds, two or more compounds, and their structures are different, then we would have structural isomers. So when it comes to structural isomers, we have four different types, and the first type is called chain isomerism. So chain isomers. And as the name suggests, these isomers are differing in their parent chain. So basically a difference in the parent chain of two or more compounds would be giving us chain isomers. So let's just take a very simple example, which is, I'm just going to draw two different compounds here and we'll dissect those. Now try to find the molecular formula for both of these compounds, and when you find them, you'll realize that both of these compounds have the molecular formula of C4H10. So their molecular formulas are the same. However, from the bond line structure, we know that the structures are different. And the main thing that you can observe is that the parent chains are different. So let's find the parent chain. The parent chain on this is this, and on this, it's this. So obviously this is a 4-membered parent chain, and this is a 3-membered parent chain. So there's 4 carbons in this parent chain, and there are 3 carbons in that parent chain. So obviously, since the molecular formulas are the same, but the chain or the parent chain, the number of carbons in the chain are differing, and therefore we call them chain isomers. Just a little heads up here, these are named differently. You would call this is a common name, by the way, this is N-butane, and this is isobutane. And obviously you can give the IUPAC names by yourself. This would be butane, and this would be 2-methylpropane. So that's the chain isomers. And so basically all we have to do is look at the parent chain. The second type of structural isomers are position isomers. And as the name suggests, position isomers are the structural isomers which arise due to a difference in the position of a functional group, substituent, or multiple bond. So let's take an example for all three of these. Let's see. So our first example is going to be this and this. You can take a moment to name these compounds. Now first, let's find the molecular formula. So molecular formula will be C3H8O. Or actually, if you want to write it a little bit better, this will be C3H7OH. And same thing here. This is C3H7OH. Now, if you take a look at the structures are varying, even though the molecular formula is the same. However, here, the parent chains are the same. They're all 3-membered carbon chains. And so the difference here is the position of this OH group. So if we number these carbons according to the lowest locant set, you'd get 1, 2, 3, 1, 2, 3. So in this compound, the first compound, you see that the OH is bonded to the first carbon. However, in the second compound, you find that the OH group is bonded to the second carbon. So here, the difference between the first one, which is this, and the second one is the position in which the OH group is bonded. So here, even if we write the IUPAC names, you would automatically get an idea of what, is differing. So here we would get propan. You could write this as 1-all. And this would be propan 2-all. So from this locant right here, you can already identify that the position of the alcoholic group is the one that's varying. So now let's go to another example, which would be this and this. Now these two, just by looking at it, you know that the parent chains are not changing, and they're both 4-membered carbon chains. And you also can identify that the double bond is present in different positions in the compound. So let's just name these, because by naming them, you directly get an idea. So this would be but 1-ene, and this would be but 2-ene. You can write the locants. Let's just write the locants here. So this is 1, 2, 3, 4, and this is 1, 2, 3, 4. Now the double bond starts at the second carbon here, and the double bond starts at the first carbon here. Hence, we put the 1 and the 2. Now we could go on with many different examples, but these two can give you an idea of what position isomers are. The third type of structural isomers that we're going to deal with are called functional isomers. And as the name suggests, functional isomers arise due to a difference in the functional group present in the compound. So there are many different subcategories. There are 6 subcategories within functional isomers, and we're going to discuss all of those right now. So the first type is called ring chain isomerism. Ring chain. I'm just going to write the short forms. So the first one is ring chain. And we're just going to discuss some examples, just so that you get an idea. So obviously, as the name suggests, the two isomers are, one is a cyclic compound, and the other one is a chain, like a regular chain compound. Now, we could take a simple example. One is this, and another one is this. Now, if you check the molecular formula on both, this would be, I'm just going to write these here. And each one has 2 hydrogens. So this is C4H8. Now this is an alkene, and this has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And there's 1, 2, 3, 4 carbons. So this is also C4H8. And now the only difference between this and this is that this is a cyclic compound, while this is an alkene. So now let's go to the next type. The next type is an alcohol's ether isomer. So this is an alcohol ether isomer. Now an example for this would be dimethyl ether and ethyl alcohol. So let's just draw those structures. So one of them is this, and the other one is this. Now you can count the number of hydrogens, the number of carbons and oxygens, and you can come up with a molecular formula, and you'll find out that both of them are C2H6O. So this is also C2H6O. However, when you're writing the structural formula or something like that, you would have CH3OCH3, and this is CH3CH2OH. So obviously here, the functional group is different. This is an alcohol, while this is an ether. So obviously we have an alcohol-ether isomers here. Now the next type is very similar to this. It is a aldehyde ketone. It's an aldehyde ketone isomer. So once again, we could go with a pretty simple example. I'm going to go with propanol and acetone. So if we were to go with, let's do acetone first. So we have that, and we also have this. So this is propanol, and this is acetone. Acetone is the common name, by the way. So here, as you can see, both of the formulas are the same. So there are 3 carbons in both, and there are 6 hydrogens in both compounds, and there's 1 oxygen in each compound. So the molecular formula would be C3H6O. Now both of them have that same molecular formula, however, the functional group is different. This is a ketone, and this is an aldehyde. So that's how we get the aldehyde ketone isomers. Now our fourth type of functional isomers is carboxylic acid ester isomers. So in this type of isomer, obviously, as the name suggests, we've got carboxylic acids and esters of the same formula. So you could have methyl formate and acetic acid. So I'm just going to write the names right here, and you can try and write the formula or the structure. Okay, so now just try it out. I'm assuming that you tried it, so let's just continue. Let's first write the structure of acetic acid. Acetic acid is CH3COOH. So this would be pretty simple. It'll just be this. It'll just be that. Now if we were to go with methyl formate, remember that the common name of methanoic acid is formic acid. And when it comes to making it as a salt form, we would use formate. So this is indicating a single carbon acid. So most likely a HCOOH. And this, obviously the methyl, is indicating a CH3. So now if we were to draw the structures, let's draw the structure. So we would get a CH3 by itself, and now remember that the carbon of the acid is not included with this CH3. So we're just going to draw the oxygen here, and a carbon, and a H. So that's how you would draw that. Now, if you check the molecular formula, it's the same for both because they both have 2 carbons. This is okay, instead of this, let's just draw the structure. It's much easier. CH3. Okay, so both of them have 2 carbons. They both have 4 hydrogens, and they both have 2 oxygens. So their molecular formula is C2H4O2. So yeah, that's that. You have the same molecular formula, just the functional group is changing. One of them has an ester functional group and the other one has an acid functional group. Now our 5th type of functional isomer is called the primary, secondary, and tertiary amines. So yeah, now this requires a little bit of thinking because they're not as easy to come up with. Now, I'm just going to draw a few examples. This is a primary amine because there are 2 hydrogens and out of the 3 bonds that nitrogen can make, 2 of them are hydrogens and the other one is an alkyl group. So that's a primary amine. Now a secondary amine would mean that 2 of them are alkyl groups and the other one is a hydrogen. So this is secondary. And a tertiary amine would mean that all 3 of them are occupied by an alkyl group. So now if you check the molecular formula, let's check the molecular formula. So this is a carbon, carbon, carbon. I'm just drawing the carbons here. So now let's check the number of hydrogens. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 hydrogens, 3 carbons, and 1 nitrogen. Now let's check the other ones. There's 3 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 hydrogens, and 1 nitrogen. And these have 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens, 3 carbons, and 1 nitrogen. The same as the other ones. So from this, we know that the molecular formula for all of these is, C3N H9. Actually, we don't write it like this. C3H9N for all 3. So yeah, that's the primary, secondary, and tertiary amine isomerism. And finally, we have the 6th type, which is pretty straightforward, and that is the cyanide isocyanide isomers. Now, cyanides are, RCN. We've discussed this before. Isocyanides are RNC. And now from that, you can just connect the dots. These 2 are isomers. And since the R is the same in both, obviously that won't be any matter. Just the functional group is changing from cyanide to isocyanide. So those are all of your functional isomers. Let's move on to the next type. So the last type of structural isomers is called metamers. And metamers arise due to different alkyl groups bonded to the same polyvalent functional group. And these polyvalent functional groups include ketones, ethers, secondary or tertiary amines, or secondary and tertiary amides, or esters. So all of these are included as polyvalent functional groups. So now let's check them out. Let's look at some examples. So this is example number 1, and we're talking about ethers. So I'm just going to this is the first compound, and the second compound is this. Now, try and compare the molecular formulas of both of these compounds. Now, obviously, we've got 3 plus 2 plus 2 plus 3, so that's 10 hydrogens, 4 carbons, and 1 oxygen in the first one. And in the second one, we've got the same. So these are both isomers. And in which aspect are they isomers? Well, according to the definition of a metamer, it's when different alkyl groups are bonded to the same polyvalent functional group. So different alkyl groups. Now, in the first compound here, let me take a highlighter. We've got a CH3 group and a 3-carbon alkyl group on the other side. So one side has only 1 carbon, and the second side has a 3-carbon chain, linear chain, in which the ester group is attached to the first carbon. Now, in the second compound that we have a CH3 group, which is the same as the other one. However, on the other side, we've got this group. So here's only 1 carbon. On this side, there are 3 carbons. However, it's still a chain, but the ester group is attached to the second carbon. So this is a different alkyl group compared to this. These two right here, the red and the green alkyl groups, are different, due to which we can call them metamers. Now we can also call this a position isomer because the ester group is attached in different positions on this 3-membered chain. We can also call it a position isomer. So this set of isomers are called metamers as well as position isomers. Now, a second example that we can talk about is ketones. So we have CH3, C double bond O, CH2, CH2, and CH3. And our second compound is CH3, CH2, C double bond O, CH2, and CH3. Now, once again, if you check the the molecular formula, they're both the same. Now we just have to compare the alkyl groups attached on both sides of the functional group. So I'm going to highlight the functional group and we'll check the alkyl groups attached on both sides. So the functional group, which is a ketone, is highlighted in gray. Now let's look at the different alkyl groups. So this is a methyl, and this is a 3-membered chain, so a propyl. And on this one, we've got an ethyl, and the same one on the other side, so another ethyl. Now here also, the alkyl groups attached on both sides are different, because here we've got a 1 carbon, here we've got 3 carbons, and on both sides of this we've got 2 carbons. So they're completely different alkyl chains, and so due to which we can call these metamers, because metamers are all about the difference in alkyl groups bonded to the same polyvalent functional group. So here, this is our polyvalent functional group. In the previous example, this is our polyvalent functional group. So similarly, that's the same case here. And we can also call these two right here as positional isomers because the position of the ketone group is differing. So here it's attached to the second carbon, however here it's attached to the first carbon. So you could just name them as both metamers and positional isomers. Now finally we've got another example. So we've got CH3, CH2, NH, CH2, CH3. That's one example. And the second part is CH3, NH, CH2, CH2, and CH3. Now, in the polyvalent functional groups, I've mentioned that only secondary and tertiary. Primary does not happen here because in a primary amine or amide, there are two hydrogens but only one alkyl group. So there can't really be a difference in alkyl group without changing the molecular formula, and hence we won't get metamers for a primary amine or amide. So we'll only get metamers for secondary and tertiary. So right here we've got secondary amides. How do we know that? Because the nitrogen is bonded to two alkyl groups and only one hydrogen. So let's go into this example. Now, if we just have to first identify what our polyvalent functional group is, and that's this. This is our polyvalent functional group. Now let's identify the alkyl groups attached. So there's this one and this one, both are identical. And we've also got this and this. So here we've got a 2 carbon chains on both sides. Here we've got a 1 carbon, and here we've got 3 carbons. So obviously here the alkyl groups attached to both sides of the secondary amine, or that nitrogen right there, are different. And because of the difference in alkyl groups bonded, we can call them metamers. So now let's talk about our final example, which is a couple of ring compounds, cyclic compounds I meant. So we've got an NH here, and the second one is this. Okay, so these are our 2 compounds. Now just check the alkyl groups attached on both sides of the nitrogen. So when we are looking at the alkyl groups, okay, first identify the polyvalent functional group. And now we're going to look at both sides of the nitrogen. So we've got this. We're just going to take it completely as one because it's a cyclic compound. And the second one is this. Now when we're looking at it, check the constituents of the ring and other groups bonded to the ring. So if I were to look at this ring right here, the first compound, we realize that there's 1, 2, 3, 4, 5 membered it's a 6-membered chain, out of which only 5 of them are carbons. And there is a methyl group attached to one of the carbons, or the first carbon. Now if we look at the second compound, we see that this cyclic compound consists of 4 carbons in the 5-membered ring, and it contains an ethyl group, so CH3, CH2. Now, if you just compare both of these, the blue highlighted and the green highlighted portion, you can automatically tell that the alkyl group bonded is different. And since they are different, since the alkyl groups bonded to the same polyvalent functional group is different, we can call these as metamers. So that's it for this video about structural isomerism. If you've got any doubts, just put them down in the comments section and we'll get to it in another video. And yeah, so I'll see you in another video, which will be about the other types of isomerism, starting with geometrical isomerism. See you.